Video will be discussing data types in C language. So it is another skill set, you can say, knowing what kind of data we should store properly and precisely. So that's why the knowledge of data types will help you to decide the type of variables. Normally in typed languages, you might have heard like typed languages. C, C++, Java, these are typed languages. Here, before you use any variable, it must be declared. It must be declared. Declared in the sense what? If you are using a variable like integer x. So this is what we call declaration of a variable x. So you say to the compiler that I need memory for storing integers. So how many bytes? That depends on the language and data types. So if it is a C language, normally in Windows and Linux environment, we have 4 bytes of memory, 4 bytes. And if it is a DOS environment, we take 2 bytes for integer. So this way, the data type will help you to allocate memory for a variable. So in the last video I discussed, when you create a variable, when you use a variable, it is actually what name for a memory location. So you are creating variables to store data. So what kind of data you will be storing, that you must specify with the help of data type. For this, the languages provide data types. So now today we will see C data types. What are the different data types available in C? So these are like containers. So you at home you have seen there are different containers. Say there is a glass and there is a cup. So this way, cup is for coffee or tea and glass is for water, any juice. So this way the container will tell you what kind of value or what you are storing in it. Say cup, it tells you that you will going to store a coffee. Similarly, the data type of a variable tells you what kind of value you are storing and how much memory you want for that. Now let us first list the different types in C. Let's list it now. So in the list we start with integer. To store integers we mean here whole numbers. Whenever you need to store whole numbers, you have to declare a data type like int. Int is a keyword. This is actually a data type and it's the keyword used. The keyword used is integer, int. So for storing whole numbers, and for storing real numbers, the language C language provides two data types. One is a floating point, this is the keyword, and the other data type is a double. So this will allow you to use 4 bytes of memory, and this is allows you to, it's more wider and quite larger number you can store with double, and it is a bytes. So integer, you can say in Linux and Windows environment we get 4 bytes. Let's assume we are using Linux, so that's why it is a 4 bytes. Now to represent character constant, in the last video I discussed there are different types of constants. So for character constants we use a char data type. So for character, the language provides you 1 byte of memory. Through char you can store characters with 1 byte. That is, the memory allocated to them will be 1 byte. And this is how these 4 are numeric and non-numeric data types. So this is a non-numeric. Character is a non-numeric. We don't use numeric. We can store alphabet digits as characters. Say A as an alphabet you can store, dollar as a symbol you can store, 2 as a digit you can store. So if you, this is a non-numeric we say. So integer and whole numbers are numeric data type. And there is one more data type available in C, that is void. The keyword used is void. It has two kind of application. One is when a function doesn't return any value, that we'll see in our subsequent sessions. In C functions we'll discuss. So it is used to mention return type. If the function is not returning any value, then we say void. Void literal meaning is what? Nothing. So that is what the meaning here we have. And this is also used to create generic pointers. We can create generic pointers. This also we'll see in future. Just remember, void is a keyword and that acts as a one of the data type. Let's go in detail. Now let's talk about whole numbers. Whole numbers or integers. What is the range of these integers? Uh, we represent by a decimal numbers using binary. Decimal numbers using binary, and we store them in binary form, binary format. Say if you have some number 9, so this will be stored as 1001. So that will be the weights of 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, like this. So here for 9 I need to set this and this. Rest of the bits will be 0. So from where one starts, from here one starts, so this is considered as a binary number. So with 1 1 2 3 4, with 4 bits, what is the maximum number? With 3 bits, what is the maximum number? With 3 bits, say all set to 1, it is the max is 7. Here with 4 bits all set to 1, what is the max? It is 15. Like this, when we set all bits to 1 in the range, say we have 4 bits, when we set all 1, that will be what? It is 2 raised to, this is nothing but 2 raised to number of bits 4 minus 1. So 16 minus 1, it is 15. Say if I have 5 bits, with 5 bits what happens? 1 1 1 1 1. It will be 2 raised to 5 minus 1, that is 31. So this way you can find what's the max number you can store with integer. So integer takes like 4 bytes. 4 bytes means 32 bits. 32 bits. So what actually we have? We have a concept in programming called signed and unsigned numbers. Signed and unsigned, this is associated only with integers. So integers we can have signed, we can have unsigned. Signed means what? We have a range, a negative range also. Negative range, negative numbers we represent with sign. And only when we have only positive numbers, there is no scope for negative numbers, 0 to positive, that time we say unsigned. These are qualifiers actually. When the data type is qualified with this, by default it is signed. Say if I say int x, so x is a signed integer that can store, what is the range of it? The range of it will be 2 raised to 32. No, it is not 2 raised to 32. Why? Because one of the bit will be used for storing the sign. So 2 raised to 31, 2 minus 2 raised to 31, 2 plus 2 raised to 31 minus 1, it is. This is the range, because one bit is you are using for sign. Say if this is the number I have, 4 bits I have, then if I use this bit for sign, I will be left only with 3 bits. So with 3 bits I can say 7. If you remove, say you say no, I don't want to use sign because all my numbers are unsigned numbers, that time you will use this also for storing the number, then it doubles the range, say 7 to 50, because all 1 you have seen here, all 4 1, it will be 15. This is how you can double. So if the range of numbers is only positive, that time you can go for unsigned. So that time you have to mention unsigned int y. Now y is a unsigned integer. What will be the range? 0 to 2 raised to 32 minus 1. So this is how signed and unsigned will play a important role in range, positive range and negative range. When we have both positive negative, use signed, and by default it is signed. No, you don't need to mention. So even if you mention, there is no any harm. Signed int x, then it is for all numbers. If you mention int z, z is also signed by default. By default, z is also signed. So the range will be 2 raised to minus 31 to 2 raised to plus, like this one, 2 raised to minus 2 raised to 31 to plus 2 raised to 31 minus 1. 1 bit is used for sign purpose. Similarly, since internally character is used or stored as an integer internally in computer, in memory. So say if you are storing alphabet A, its integer value will be stored. Its integer value is 97. This value we call it as ASCII value, American Standard Code for Information Interchange. It is, that is the meaning or long form of ASCII. ASCII is American Standard Code for Information Interchange. This is a standard, some standard. So as per the standard, they have given some ranges. Say capital A to capital Z, the range will be 65 to 90. This is the number. So any alphabet if you take, it is associated with some integer. Since character is an integer, character could be signed and character could be unsigned. So when we say char symbol, it is by default it is signed. So if you want, if it is always a positive range, then you can go for unsigned char sim. So it doubles the range. By saying unsigned, what we do, we double the storage capacity. So this is how data types play a very important role, and you should know the conversions also. Can we convert from one type to the other type? So let's see now type conversions. So in C++, the implicit conversions takes place. Implicit conversions takes place, and even you can have explicit type conversion also. Explicit type conversion also. That explicit type conversion we call it as typecasting. Typecasting, we have to typecast. For instance, if I say int a and there is a float b is equal to 2.5. So a is an integer variable, b is a floating point variable. So when you say b is assigned to a, b is assigned to a, so here automatic conversion is taking place. That automatic we call here implicit. We call that as a implicit. Automatic means implicit. So what happens? The real number is converted to integer and then it will be stored. Say 2.5 will be converted to integer. So integer conversion means what? The fractional part will be removed. So it will be truncated. So it will be only 2. So now if you print the value of a, it will be only 2 because automatic conversion is taking place. So I'll give you another example of automatic conversion. Say if I have int a as 5 and b as 2, then I'll take one variable float c. C is equal to a by b I do. So this is how I divide. So I expect when I say print c, what output I am expecting? You pause and can you guess what it will produce? It will produce the output as 2.0, not 2.5. Why? Because the concept of implicit conversion comes into picture here. So when an integer divides 5, another integer say 2. So integer by integer is integer in programming. So this is an important fact you should remember. So integer by integer is integer, so the result will be 2. And this 2, since you are assigning to a floating point variable, it to a floating point variable, it will get automatically converted to float. So it becomes 2.0 and this way you will get the output. So now I want it to be 2.5. Then what you need to do? typecasting, and that typecasting we call it as a explicit typecasting. Explicit typecasting we call. We need to typecast explicitly. Say now here you have C. So one of the operand, say there are two operands here, A and B. One of the operand you must convert to float. Say if you convert, now A is temporarily in this expression converted to float, and then you are dividing by an integer. So float by an integer is float, real number. So this is the one way, or you can convert the denominator to float. So you can convert B now. Now B is converted temporarily in this expression to float, and this is also the result is float. Integer by float is float. So you get in this case also C 2.5, and in this case also C 2.5. This sort of the knowledge of typecasting is very important. Otherwise you think that it is taking automatically, it happens. So you expect the output to be 2.5, but you are getting it as a 2.0. What is the reason? You don't know. If you have an idea of typecasting, that way this is one of the important skill, knowledge of data types and typecasting. That's why I have discussed here. Hope you enjoyed the session, and if you just let me know how did you like this session in comments. Thank you so much for watching.